over the same cable alongside USB. And that's what we've done with Thunderbolt 3. So we say, what's next? And Thunderbolt 3 is what we've done. This brings Thunderbolt to the USB-C connector. Now, the code name for this is Alpine Ridge. Some of you may have heard or seen that before. So that's the Intel solution for Thunderbolt 3. So as I mentioned, Thunderbolt 3 brings Thunderbolt to USB-C and a whole lot more. It really, as we said, is a USB-C that does it all. It really fulfills the promise of the USB-C connector. That connector has a lot of potential, a lot of flexibility. Thunderbolt 3 really fulfills that promise and delivers all you need to connect to any device or display or anything. So we'll talk about, there's really 4 vectors of value that Thunderbolt 3 brings to this. More protocols, speed, pixels, and power. And I'll talk about each one of those one by one. More protocols. So you can see that you have USB. In the case of Thunderbolt 3, you have USB 3.1, 10 gigabits per second, the fastest USB. You have Thunderbolt, 40 gigabit Thunderbolt, the fastest Thunderbolt version. You have DisplayPort, 1.2. These are all native protocols that can connect up to a computer with a Thunderbolt 3 port. And then, of course, PCI Express and DisplayPort you get within Thunderbolt as your data and display protocols within the Thunderbolt packet. So putting these all together on a single connector, you're able to connect literally to any dock, display, or device. You can connect to Thunderbolt devices, of course, and we'll talk later about even adapting to existing Thunderbolt devices. You can connect to every display either natively with DisplayPort or through an adapter to HDMI, DVI, VGA, and of course, docking stations that would use Thunderbolt. And that includes billions of USB devices as well. So all of the USB devices that were ever made can connect into this port, and of course, being the 10 gigabits per second, even the newest USB 3.1 devices can plug in and work on this port. So what that means is, for an end user, anything with a Type-C connector can plug in and it just works. It's going to work. Now, you can't always say that with any Type-C connector. If it's maybe just USB, some of these devices won't be able to work when plugged in. So we think that having a superset capability, we really deliver the best Type-C. Anything will plug in and just work. Talk a little bit more about the USB 3.1 controller that's in the Alpine Ridge chip. This is a 10 gigabit per second controller, the fastest controller. And in fact, it's really going to be when it goes to market, among the industry's first to market as a 10 gigabit USB 3.1 controller. So we're very excited about that. And again, it can connect to any USB device ever made. So the second vector, more speed. As we talked about, you have 40 gigabits per second Thunderbolt link. On there, you can run data and display with PCI Express Gen 3. So this is the first time that Thunderbolt is supporting Gen 3 instead of Gen 2 PCI Express, so it doubles the performance there. And also DisplayPort. And the DisplayPort is double video bandwidth of the previous generation. So you have double the speed, double the data bandwidth, double the video bandwidth of the previous generation of Thunderbolt, and 4 times the data and twice the video bandwidth of any other cable. So again, if you have a single DisplayPort cable, for example, you only get 1 stream of DisplayPort. If you have a Thunderbolt 3 cable, you can get 2 streams of DisplayPort, so double that bandwidth. Being able to connect to 2 4K displays from a single cable. In fact, we have a demonstration back there, which you can see after we're done. that has a dongle connecting into one port and then connecting out to two 4K displays. So we're very excited about that capability. The other thing is with this kind of speed, what does that mean to an end user? You can transfer a 4K movie in less than 30 seconds. Now, for those of you who've been following Thunderbolt, maybe you've heard us say in the original Thunderbolt, you said you could transfer an HD movie in less than 30 seconds. Now this is 4 times faster, so 4K is 4 times more data than HD, so now you can do a 4K movie in less than 30 seconds. Another example, maybe with the GoPro video, because we talked about the SD cards, you can transfer 3 hours of GoPro video, 4K GoPro video, in less than a minute. So just some examples of what this really will mean to end users. The third vector is more pixels. So in this case, as I mentioned, 2 4K displays. You have large displays with amazing detail. You have twice the video bandwidth of any other cable. So you have 2 streams of DisplayPort. That's 8 lanes of DisplayPort, for those of you who are familiar with DisplayPort 1.2, 4 lanes per stream, to be able to do two full 4K, 60 hertz, 60 frames per second displays that you can connect to. Or you can have a single cable to plug into a 5K 60 hertz display, which if you've seen a 5K display today, requires now 2 DP cables, and you can do it with 1 Thunderbolt 3 cable. So it's really, again, the only computer port that can connect to 2 4K displays or 1 5K display with a single cable. And the fourth vector is more power. As we mentioned, you can have up to 100 watts of power in either direction. So what we think are the most compelling uses of what to do with all that power is, number one, being able to charge your notebook from a dock or a display. You just plug in the single cable into your notebook and then you charge your notebook. And then also going out of the notebook or computer to a bus powered device, you have 15 watts to bus powered devices. And this is an increase, a little bit of an increase over Thunderbolt 2 from 12 watts to 15 watts. So now actually our device vendors are even more excited about being able to do even faster performing storage, higher capacity, portable displays, high performance adapters like 10 gig adapters. There's a lot of interest in doing a lot of different kinds of bus powered devices like that. By the way, this power is based on the USB power delivery spec. So it's not anything unique. It's based on the industry standard USB PD spec. So everything I talked about and all the protocols that you get are on a computer port that I was referencing there. So let's talk for a minute about device configurations. You can see here an example of some devices daisy chaining on Thunderbolt port, Thunderbolt 3 port. If you're familiar with Thunderbolt from before, it daisy chains up to 6 devices. Thunderbolt 3 is no exception. You can daisy chain up to 6 devices. But another unique thing about Thunderbolt 3 is that the second port, if you have a 2-port device, you plug one into the host, you have another one that you can plug in something else into. That second port has all of the capability of the host. It has USB, Thunderbolt, and DisplayPort. So you can plug in USB devices into that port, and they'll work with that computer. So it's very exciting, very powerful technology to not only be able to connect Thunderbolt devices to that port, but also USB or DisplayPort at the same time. So what can you do with all that capability, right? So we say more possibilities. We think that there's some very exciting usages that are really just emerging now that Thunderbolt 3 can really enhance and bring to the end users. So there's a lot of different things we can talk about, but we want to focus on 4 areas, and we also have some demonstrations around the room that you can take a look at afterwards. The first one is 4K video, single cable docking, external graphics, and Thunderbolt networking. So we'll talk about each one of those. 4K video is becoming more and more popular. It's becoming more and more mainstream. 4K TVs and displays are under $9.99 now, in some cases, $500 US. And that's just continuing to ramp. The sales are ramping very quickly. 4K content is becoming more prevalent. GoPro has 4K cameras for consumers, so it's not just a high-end professional studio capability anymore. Consumers are using 4K video and creating it for their own content. So it's really starting to expand. So what does that mean? The challenge that it brings is that it's a lot more data and a lot more bits than before. And so one example is that two 4K displays has nearly 16 million more pixels than an HD TV. So now if you want to move that data, all of those pixel bits, you're going to need a very big pipe for that. Second example is moving, like a file or the content. HD to 4K is a huge jump, significantly a bigger increase than, let's say, SD to HD was. So 4K is 4 times the amount of bits than HD. So that's the big challenge there, and that's really why if you're doing anything with 4K video, you really need Thunderbolt. You need Thunderbolt 2. A lot of people are using Thunderbolt 2 today for that. You're going to need Thunderbolt 3 as you go forward. And so the exciting thing here is with Thunderbolt 3, you can create, edit, display, archive 4K video simultaneously on the same cable. You can have your displays, your archive storage, your computer, everything all connected on a single cable line to be able to do that with 4K video. So again, that's really the only port that you're able to do that with on a single cable. The second usage is single cable docking. So we're very excited about this. I know most of you probably just came from Kirk's keynote and heard about no wires docking, wireless docking. Intel supports both capabilities.
Good job.
Single cable docking is one cable away from no wires, but it's actually very exciting because you can do everything you need with a single cable. You can connect to all of the displays and devices that you need. You can also, at the same time, be able to quick charge your notebook battery. So again, very exciting to be out on the road with your notebook, come back with a single cable you plug in, you're able to get everything on your desktop while you're charging your notebook very quickly. So we think this is actually a very exciting usage area, particularly in the business space where docking is more prevalent. But we also think that even in the consumer space, cable docking is simpler and easy, and we think that it's also going to become more prevalent. This just shows some examples of maybe a user configuration and how much bandwidth they're using or how much they need to do certain things. So you can start with kind of a mainstream example here. We have a QHD display, which is kind of a mainstream display today. USB 3.0, 5 gigabits per second, Ethernet connection maybe. Even here, you're exceeding the USB limits and getting up near 15 gigabits per second. The middle one is maybe you move up to a 4K display, have USB 3.1, 10 gigabits per second, and Ethernet. Now you're already up and above the 25 gigabit realm. And then if you're really doing some meaty, some rich media projects, productivity, content creation, things like that, you have two 4K displays, you can see you very quickly get above, you get to 40 gigabits per second and beyond if you want. So we see that really when you're using multiple devices and data and display together, you very quickly need all this bandwidth and more.